Welcome to myprojectbazaar.com. Let me discuss about the process real-time people tracking in a camera network. Let me see about the process real-time people tracking in a camera network. In this process, we are proposing a scheme in order to track the persons in the video. First, the input video is taken and it is converted into frames. Each frame is pre-processed by applying Gaussian filter to the frames. Then the objects were tracked using SAR particle filter. A SAR particle filter has three basic functions such as transition, likelihood, and resampling. The transition function generates free state particles from the previous item. The likelihood function maintains the identity of the tracked subjects within and between views. Likelihood function is needed. Likelihood is based on the correspondence between projected ellipses and the foreground pixels determined by emoji model and a comparison of the mapped surface color or texture with the image pixels. An additional term suppresses distraction when two or more subjects are in close proximity. Perhaps resampling draws the samples based on the importance sampling, and it is implemented by independent sampling. Importance sampling is a general technique for estimating the properties of a particular distribution while only having samples generated from a different distribution rather than the distribution of the interest. For generating sample numbers at random from any probability distribution given its cumulative distribution, then based on that we are detecting the objects using the background subtraction method, which detects the objects based on the frame differencing method, and after that we are applying the previously discussed SAR particle filter. Finally, we get the tracked objects and we are plotting an ellipse over the tracked objects, and we are calculating the multiple object tracking accuracy in the process. In this paper they have given some hardware implementations. They are not implemented, only the possible software implementations are done, and we are using the SPR particle filter. We are tracking the moving objects in the video. If we see the flow of the process real-time people tracking in a camera network. Initially, the video is loaded and it is converted into frames. The frames were pre-processed. Precious bits were wasted on a noisy video. Color correction can mask noise and it is used to improve the overall image quality. Detailizing, scaling, and color space and sampling are also used for video pre-processing. Comma correction is also an important step in the pre-processor because PC mentors tends to be darker than television sets. Here we are using some filters in order to remove the noises in the input video. So we are using Gaussian filter to remove the noises in the video. Then we move on to the object tracking step. Here we are using background subtraction. Here we are using frame differencing background subtraction. We subtract the original frames from the empty background in order to get the foreground information alone. So after object is extracted, we are tracking the objects using SRPF particle filter. Here in the SRPF particle filter there are three steps: transition, resampling, and likelihood. So in the transition step, this transition function generates a pre-state particle from the previous iterations. Then in the likelihood step, the identity of the track subjects within and between views likelihood function is necessary. So likelihood is based on the correspondence between the projected ellipses and the foreground pixels determined by the emoji model and the comparison of the mapped surface or the color of the textures. And in addition, suppression suppresses distraction when two or more subjects are in closely proximity perhaps. So the resampling step draws samples based on the importance sampling, and it is implemented by inversion sampling. Importance sampling is a general technique for estimating properties of a particular distribution while only having samples generated from a different distribution rather than the distribution of interest. For generating sample numbers at random from any of the property given its cumulative distributed function. Then we are measuring the performance of the overall tracking process using multiple object tracking accuracy. Here it is calculated and the value is displayed. We are getting about a 95% in the multiple object tracking accuracy. So the proposed method tracks the objects even if it is uploaded by some static objects. Let me see the execution of the process real-time people tracking in a camera network. If you want to run the code, select the file main.m, which is located at the source code folder. Right click it and click on run file. You will get the guide window which is required in order to run the code. First, initially select the video that is given in the data. So when we select this video, the video will be played here and it will be converted into frames. While clicking on frame conversion, now the video is converted into frames and the results were here. Then we apply pre-processing to the input video frames. Here we are using Gaussian filter in order to remove the noises from the frames. Then we are segmenting the background region from the input frame in order to extract the foreground objects alone. So like that the foreground regions were extracted and next window will be open. When we click on object detection, here we are tracking the moving object using ellipse plotter, and now we are tracking the same product using the SARPF particle filter. Here we are tracking the moving objects in ellipse and by using the SAR particle filter. Thus we are tracking the moving objects in the video using SAR particle filter, and hence for that we are using background subtraction mechanism to remove the background information and to get the exact foreground objects from the image, and then we are tracking the objects based on the measurements of the identified blobs. Thank you.